September 2020 was a milestone day for Tesla CEO Elon Musk. The electric vehicle industry was abuzz with anticipation as Tesla hosted its much-awaited Battery Day. During this landmark event, Musk unveiled what was termed a game-changing innovation, the 4680 battery cell. This was regarded as the solution to several challenges that had long plagued electric vehicles, revolutionizing not just Tesla's future, but the entire landscape of EVs. Fast forward to 3 years later, and the picture looks quite different. While Tesla has made huge strides, the big promises surrounding the 4680 battery remain largely unfulfilled. This gap between the high expectations set during Battery Day and the current reality poses one big question: what went wrong with the 4680 battery cell? Let's find out. One of the most tempting promises Tesla made was the significant increase in driving range that the 4680 battery would offer. A longer range would not only make electric vehicles more appealing to consumers, but also remove range anxiety, a common concern among potential EV buyers. Another was its potential to drastically reduce manufacturing costs by innovating the battery design and production process, thereby making electric vehicles more affordable. The 4680 battery was not just about individual vehicle improvements, it was about scaling these benefits across millions of vehicles. Tesla's vision was to ramp up production to unprecedented levels, making electric vehicles accessible to a broader audience. Despite all the promises, the 4680 battery was only available in the base Tesla Model Y, and it didn't significantly outperform its counterparts in terms of range or cost. In fact, that version offered less range and power than the long-range Tesla Model Y and only cost about $3,000 less. Tesla has also stopped selling the base version, raising even more questions. Now, when it comes to the 4680 battery, one of the most glaring issues is the bottleneck in production. Tesla is far from the numbers needed to make a significant impact on the electric vehicle market. In February 2022, Tesla produced 1 million 4680 cells at their pilot line in Fremont, California, while in December 2022, they manufactured 868,000 cells in 7 days, combining production from both Fremont and Giga Texas. And in June 2023, the company announced that they had manufactured 10 million 4680 cells at Giga Texas. While these numbers may seem impressive at first glance, they fall short when considering the scale at which Tesla aims to operate. That's because Tesla has set ambitious targets for its 4680 battery production. During Battery Day, they predicted that Giga Texas would reach an annual production capacity of 100 gigawatt hours by 2022 and scale up to 3 terawatt hours by 2030. However, as of summer 2023, Tesla is nowhere near these goals. To put it in perspective, the 10 million cells produced at Giga Texas equate to less than 1 gigawatt hour of energy storage capacity. Each of the 4 battery lines at Giga Texas is supposed to have a total capacity of 25 gigawatt hours per year. So far, Tesla hasn't even hit 1/25th of one line's capacity after at least 6 months of production. This significant gap between Tesla's predictions and the actual production numbers raises questions about the company's ability to meet its ambitious targets. Now let's see what technical challenges Tesla faced in the production of its 4680 battery. One of the key innovations that Tesla introduced with the 4680 battery is the dry electrode process. Unlike the traditional wet process, which uses liquid solvents to bind the active material to the metal foil in the battery, the dry process aims to eliminate the need for these solvents. As of now, Tesla has only successfully implemented the dry electrode process for the anode side of the 4680 battery. The cathode side still relies on the traditional wet process. The dry process requires high pressure to bind the active material to the metal foil, exerting a lot of shearing force on the mixture. This force can damage the active material, leading to inconsistencies in the battery's performance. Achieving consistent results with the dry process has also proven to be a significant challenge. The process often results in a thicker electrode with more binder particles, reducing the battery's energy density. Tesla has also opted for a pure graphite anode in the 4680 battery, deviating from its previous batteries, which used a mix of graphite and silicon. The absence of silicon in the 4680's anode is noteworthy because silicon generally allows for higher energy density and faster charging rates. The use of pure graphite likely stems from the challenges associated with implementing the dry process with silicon, which is more susceptible to damage under high pressure. Despite the challenges and bottlenecks, Tesla has not thrown in the towel yet. During their March 2023 Investor Day, Drew Baglino, Tesla's Senior VP of Powertrain Development, provided valuable insights into the company's ongoing efforts. He emphasized that they haven't stalled out yet on the rate of progress, indicating that work is actively underway on both the anode and cathode sides of the 4680 battery. But how is Tesla looking to solve these challenges? Given the partial success in implementing the dry process for the anode, Tesla is likely working on perfecting this technology for the cathode side as well. Tesla may also use alternative materials or combinations that can withstand the shearing forces in the dry process, aiming for more consistent and cost-effective production, while continuing to invest in its production facilities, like Giga Texas, to increase the production rate of the 4680 cells. Also, with the inconsistencies in the dry process, Tesla is focusing more on quality control measures to ensure that each 4680 cell meets the company's high standards. Now comes the big question. Will Tesla be able to fix these issues? Tesla's journey with the 4680 battery has been a roller coaster ride. However, they're committed to overcoming these challenges. The company's ongoing research and development, as evidenced by statements from senior leadership, indicate that Tesla is far from giving up on the 4680 battery. But what do you think about the measures taken by Tesla? Can they overcome these challenges? Let us know in the comments below. Thanks for watching, and see you in the next one.